Hello, everyone. My name is Yuan Kang. I come from China, DiDi Chuxing. And we worked on HBase for several years. And this presentation, I will introduce how we do applications in DD with HBase. The agenda shows that the first part, I will introduce our company and our HBase team. The second, I will introduce our Didi HBase platform, which holds all our applications. The third part, I will introduce the application and the solution we did for our business. The fourth, I will introduce the challenge and the future work we want to do. Okay, how many people here have seen this film, Silicon Valley? Hands up. Oh, yes, I am a fan of it. So this balloon is DD. Yes, you can see all around the Silicon Valley is famous company. They are great, but Didi is a new one. We have passed our 5th birthday last week, so we are so young in here. What does Didi do in the past 5 years? This is our app here. So you can see we have so many traffic services here. The Express people use mostly, and the minibus you can take for a short trip, and cheap. The bus you can look up the bus number in Didi app, so you can take a bus. And the electric car, just you can take a car like Benz, BMW or Audi. It's expensive, and you can also call a carpool to share a seat with other people. It's cheaper than Express. Also, traditionally, you can call a taxi. Primarily, car is just between the Express and the electric car. When you have a drink in the bar, you just can call a designated driver for you. Maybe if you want a robot or AI send the car to you, you may wait for years. Yeah, maybe in the future. Oh, okay. The travel run you can call for the car driver. And if you want to drive by yourself, you can rent a car. We will send the car to the place you choose. It's different from the other car renter. Oh, the tax for aged people. We know aged people does not understand how to use there's service about. So we offer them a function that they say to the app, I want to go to some place. So a taxi will pick you up and deliver you to the place. The last is offer a sharing bike. When I send the presentation to Stack asked me twice, what is sharing bike? Can somebody tell here? Sharing bike. Oh, nobody knows. Oh, sharing bike. Sharing bike. When I come to San Francisco, I know you just can ride a bike in Stanford University, but not in city. City is so so big. But like in Beijing or in New York, the city is crowded. So we must take a bike to the a railway station or subway station. We also ride bike for environmental protection. Okay. So this is our traffic service. Okay. We are the world's leading mobile transportation platform, and over 20 million rides on a daily basis. We have served 400 million passengers and 17.5 drivers, 400 cities. Our mission is to redefine the future of mobility, and our vision is to become a global leader in smart transportation and automotive technology, the world's largest operator of vehicle networks and a global leader in smart transportation system. Okay, let's introduce my team. This is me, Yuan Kang, and Li Yang, Zhang Hanzi, Yao Jinyi. We attached to big data architecture department. We cooperate with Hadoop, Hive, Spark, Flink, Druid team closely. We have 3 clusters. One is a storage cluster in location B and location A, a computer cluster and location B, a storage cluster and location B. The location A is the same place with the Hadoop cluster. It's just do the job about offline job. Location B is for online business or streaming job. We have more than 50 business and 160 tables. The candidates batching job result storage, online writing, reading, persistent for streaming jobs. We have achieved 99.95% availability here, and I will explain why we can achieve this. The next. We use the HBase version is 0.98.21, and we backport the region group patch HBase 6,721, and we fix the Swift2 bug to this vision. The multi-talent problem is here. When we serve the people around, the users can use the table badly, and a bad table can pull down a cluster, and even you didn't know who did it here. So we need a region group feature here. This is an example. When in a cluster, we divided region servers in 2 region groups, group 1 and group 2. Then tables, there are 3 tables, table 0, table 1, and table 2. They are divided to region server group 1, region server group 2. When the table is splitting, compaction, or do anything movement, the HMaster will assign the table's region in the right place. So the region is controlled by the HMaster assignment. Okay. And this is the initial divided, and you can move the table between the group. I can move the region server between the group, and you can also create or delete the group here. There are so many advantages here. It's loaded important use case from others, and easy to manage. And we web UI use group operation tools, and it's elastic to assign resources to different peoples, and we can make a different conference in one cluster. Maybe for different machine types, business, testing, and so on. Easy to compute the cost of the business, and easy to upgrade the region server in one group before we do it in the whole cluster. So we have computed the cost here. When small table use a shell pool, their cost is computed table size multiple x. X is the cost for cost per GB, and we compute cost for specific group. Just use the region server count multiple y. Y is the cost per region server. This is we have done improvement for this feature. We add the web UI to show groups. So you can see group name column, servers column, and the tables column. And we fix move table bugs and additionally create table handler bugs here. Now this is the code. When we move the tables between group, the original code does not have checked whether the table exists in SRC group. So we added this check here. But in create table handler, it doesn't need to have this check. So these two parts, we just invoke the move table inner functions here. Okay, this is our Didi HBase Service platform. It's a website for users. So it's there are 3 parts here. HBase introduced for the people who doesn't know HBase, and the popular usage for the people who is deciding which one database to use for their applications. And the third part, apply your project lead you to our HBase cluster. So when you how can users to use our HBase cluster? First, you create a project and tables. Project contains some information about the name, the people who come from the department, and their account. We just grant the permission in this page, so they can access their tables. The next is create table. We just support the ordinary HBase table and the Phoenix table here. And when user create a HBase table, they can choose the split policy, hex string or uniform. And when they will create a Phoenix table, they just use circle. Yes. And this is the workflow. Yeah, several steps. Create or modify the project. This is step 1. Create a modify table. Step 2. And we developers will approve this apply. The first, the operational will approve this this project, and then we create the test table in our pre clusters. Next, we will create a prod table in our prod clusters, and finally, we complete this project to our cluster. Okay, and there are other informations here. Maybe the project introduced, and the user info, and the test conf, pro test conf, and the prod conf, so people can easy to get their information, not just asking for our people. We have only 4 people here. And when they put their tables in our cluster, we offer the monitor page here. This is different from the common monitor. We just regroup the region metrics to table metrics, so people can see their tables read per second and write per second here, and they can get a warning when the TPS or QPS is high or is too low. So it's just the monitor for the users, not for the for the infrastructure team. This page, and they can get their bill. So users must care for their cost when they use our clusters. We have used Phoenix most recently. The Phoenix advantage is easy to use for RDBMS users. They used to use JDBC or Circle in their former workers. And the Phoenix auto sorting table for performance and hotspot avoiding. And we can easy to expand to our users, just like Big Circle. But the disadvantages, there are some bugs, like when you were ordering a vector return and unstable statistic info caching. Not good in join case. And there are so many other hotel systems like Presto, Impala, Spark Circle, or Killing. There are 2 cases we have used successful. One is low time step, and the second is multi-dimensional table schema. No time step for metrics. We the page I showed before. Monitor table, write, read, and storage, and locality, and the memory store size for table, we just use Phoenix table to storage the data. And when we use no time step, it can scan the data in a time range, so we can quickly to query recent data. And when because we use Phoenix, so we can easy to compute average, max, meaning for the metrics. Second is multi-dimension table schema. This is just like the killing, but we just use the Phoenix to complete this job. So the first you want to run a MR or Spark job to compute a BI reporting data. The result will be many dimension combination result like city, gender, age, business type. So we design a prompt key like this: the job ID and the job when it did, and the dimension 1, dimension 2, dimension 3, and there are about 20 dimension at most. The value is dimension name array and the dimension value array. This place we need a hash map, but Phoenix does not support hash map, so we just divide the map into 2 array here, array type. And this can fit nearly all the multi-dimension reporting business. In Didi, we have many multiple language clients, and we have few Java clients here, and more C++, Go, Python, and PHP clients. So we use Swift 2 and QueryServer most a lot, and we solve the many problems when users use this two. And we opened the access controller in HBase, so people can access their table with the permission we have given to him. Next, I will introduce some application and solution. First is the Hadoop monitor. We just know the Hadoop's name node contains FS image and geo history info. We collected it every day and put the information to the HBase, exactly the Phoenix table. So we can query the date in those two files and show them on the website. This is the Hadoop monitor website. We can know increment storage per day, increment files count per day, and other informations about the MR job or Spark job. Second is the GPS application. We collect text traces, express traces, primary traces in Kafka every 3 seconds. So it's a huge data here. We use Storm to put the data from Kafka to HBase. There are several systems depend on this state, just like customer service, visualization, operation, map. Okay. So this is the Loki. Loki is like this. The user ID and the time step here. Next table is resolve the geo hash and the time step and ID. The geo hash. What is geo hash? It's simply an index in 2 dimensions. Fit HBase Loki perfect. They have 2 points. A same prefix code result in a nearby place. A query Loki prefix can location a region whose area directed by prefix length. Oh, so this is the geo hash. So you can see the prefix is the same in the nearby places. WX4. We have done online machine learning with HBase. When the data is the order and the driver passenger tracing is in the Kafka, and the trip will be joined here in Spark streaming. There are some validated info, and the Spark streaming will carry the data in the ETA server and the data future trained. Time cost future the data will storage and query in the HBase, and the this online training result will dump to the HDFS and the model training systems. So, training data by Spark every 30 minutes, pick up data by city from HBase in 5 minutes, compute the ETA in 25 minutes. Okay. Last application is trafficking cloud. There are high volume throughput and little read. There are load traffic info and POI data, heat map, right with Spark job. Oh, this is our architecture. It's Kafka and Hive, Spark Circle, Phoenix, MR, Spark Core, HBase Yarn, and HDFS here. Oh, the challenge and the future, we are more connected with other big data framework. Hive Phoenix HBase handler integration with Hive. Use Hive Circle to query Phoenix. Easy to load data from Hadoop cluster. Join with Hive table. A Spark Phoenix HBase handler. Last page, we want a more stable HBase. So we plan to upgrade HBase 1.x. OLAP extend just like Killing. Thrift load balancer and outer group balancer. And a more powerful datasets for users to use. So that's all. Thank you.
Okay, we really only have time for one question, I think. So let's make it a good one. Who's...
Okay.
No takers? Okay, thank you very much.